The huge city of Shanghai is growing rapidly and is in constant need of more space, even beyond the natural borders of the Yangtze Delta. The Shanghai-Changjiang Under-River Tunnel Mega Project improved the link between the Chongming and Changxi River Islands in the Yangtze Delta and the Shanghai metropolitan area, right on time for the World Expo 2010. The two 7.47-kilometer-long tunnels run beneath the Yangtze River, the longest river in China, and were excavated with the largest tunnel boring machines the world has seen so far. These mixed shields have a diameter of 15.43 meters. The greatest challenges in this project were the large 15.43 diameter cutting wheel and the adaptation of the machine technology to the geological and hydrological conditions beneath the river. Each of the two tunnels integrates two levels. The upper level accommodates a 3-lane expressway. The lower level provides space for a planned subway line. At its deepest point, the tunnel runs 65 meters below the surface. Due to a groundwater level of up to 47 meters above the center of the tunnel, the mixed shields are designed for a maximum working pressure of 6.5 bar. Let's take a look at the example of the world's largest mixed shield to demonstrate the principle on which Heron Connect hydro shields work. The configuration of the openings and the excavation tools on the 15.43-meter cutting wheel means it is perfectly adapted to the difficult geological conditions. The cutting wheel's 6 main spokes can be accessed from behind the shield under atmospheric conditions to allow the tools to be replaced. This makes diving operations for tool replacement obsolete. The cutting wheel is driven by a total of 15 electric motors, with a nominal power of 250 kilowatts each, and a maximum torque of up to 39,984 kilonewtons. There are 3 airlocks for maintenance. The center lock is movable and can be linked to the pressure-protected interior of the cutting wheel. "19 triple hydraulic cylinder presses produce a maximum thrust force of 203,066 kilonewton to move the mixed shield forward. The cylinders brace themselves against the last previously installed lining ring and push the mixed shield ahead. The erector lifts the individual concrete segments and positions them precisely for installation. The first gantry is located behind the erector. Due to the machine's large diameter, the backup system has 3 levels, so that it can accommodate the slurry pump, control cabinets, bentonite supply system, and hydraulic pumps. The segment feeder is mounted on the first gantry to transport the segments to the erector. The second gantry forms a bridge between the second and third levels. The third gantry travels on the backup rails, which are laid next to the road element, and then taken up again behind the gantry. The total length of the mixed shield up to the third gantry is 135 meters. The mix shield works in two phases. The first phase is the installation of a lining ring. Concrete segments are supplied by the segment feeder and subsequently lifted by the erector. In the installation area, the hydraulic cylinders are temporarily retracted in order to provide enough space for the new segment. The segments are positioned with millimeter precision and secured by cylinders immediately after their installation. After that, the segments can be bolted into position. The conical keystone is inserted from the front. When a complete lining ring has been installed, the bottom segment, which is a retractable module, is put in place in the lower section of the last previously installed ring. It serves as a foundation for the gantry, which can now follow. The lining segments are delivered by special job site vehicles from the surface to the rear part of the machine. On the third level, a segment transport crane moves the segment from the rear part of the machine to the front. The crane is also used to transport the grout container on the first gantry. The segment transport crane moves the segments via the bridge of the second gantry to the transfer area of the first gantry. The segments are lifted and turned by the transport crane and then positioned on the segment feeder. The segment feeder moves the segments under the first gantry to the erector and into the take-up position. The excavation chamber is situated behind the cutting wheel and separated by a submerged wall from the working chamber. The excavation chamber is completely filled with bentonite, and the working chamber is approximately 2/3 filled. The two chambers are connected in the form of communicating pipes via an opening in the submerged wall. A filter cake is generated ahead of the cutting wheel by pressurizing the bentonite in the working chamber with compressed air. The soil and the groundwater pressure can reach up to 6.5 bar. Changes in the geology and consequent changes in pressure can be compensated by adjusting the pressurization. The excavated material falls into the excavation chamber. Small-sized grains are largely dissolved in the bentonite, whereas stones and debris sink to the bottom. The opening of the suction pipe is protected by a nozzle grid. Two agitators and mobile flushing nozzles guarantee smooth removal of the excavated material. The excavated material is pumped through the suction line to the separation plant at the surface. Here, the soil material is separated out and removed from the bentonite suspension, and the clean suspension is transferred back to the slurry circuit. To provide an optimum flushing process, the feed line supplies several nozzles distributed around the TBM circumference, which can be connected during peak load times. As tunneling advances, the feed and slurry pipe connection is extended. Flexible extension lines are installed on the third gantry to prevent the pipelines uncoupling after each thrust phase. Sliding shoes compensate the machine's movements. The pipe wagon is released after the final position has been reached and then returned to the starting point. The extension pipe is then installed in the generated gap. The 6 main spokes of the cutting wheel are accessible under atmospheric conditions. For tools to be replaced, the cutting wheel is halted in the maintenance position. The accessible spokes allow the maintenance staff to reach the worn tools and replace them. The tunneling team installed 7,472 lining rings, each made up of 10 segments. 27 million cubic meters of soil were excavated for the tunnel and had to be removed. With top daily performances of 26 meters of tunnel and top monthly performances of 142 meters, the mix shields drove the two tunnels accurately in a period of 20 months. The two largest mix shields in the world, with diameters of more than 15 meters, set new standards in tunneling. This project is an example of successful large-diameter mechanized tunneling. Mix shield technology is a convincing solution for long and deep river crossings, since it is able to cope with loose soil and high water pressure, even for large-diameter tunnels. The first breakthrough was celebrated in May 2008. The second followed in September of the same year. Finishing work on the tunnel started 1 year ahead of schedule. The two tunnels were inaugurated and opened to traffic on October 31, 2009, 9 months ahead of schedule. Since October 2009, the tunnels have connected Changxing River Island to Shanghai, allowing the 600,000 island inhabitants to drive between the two. With its full-service tunneling philosophy, Heron Connect supports rapid construction progress and creates project-specific service packages that include all services required on-site. A global network of branch offices, subsidiaries, and associated companies working in related fields allows us to provide consultation and comprehensive services around the world. Solutions everywhere.